Let's discuss the question number 37 from test series 4. This is from theory of machine, basically the vibration part, vibrations. Okay, so a system is given where you have two springs K1, then in between you have a damper C, and then you have another spring K2, and so all these three are connected to a mass M, which is on a roller. So rolling friction you can calculate because rolling friction is very less, and time varying force F of t is applied. So what is asked is the differential equation of motion for the system is asked. Simple. Let's draw a free body diagram for mass M. So let's say if the amount mass is displaced by amount x. Okay, say I just displace this by an amount x. Okay, so then what are the forces on the mass M? Free body means what? The forces that are coming because of the other bodies on this body. That is what you have to represent in the free body. So when I displace this mass by amount x, the spring K1 and K2 are stretched by amount x, so they will try to come back, and that's why they apply a pulling force on mass M1. So that is nothing but K1 into x and K2 into x. So now at distance x, when it is stretched, it might have velocity x dot. The mass at a distance x from the given position, it may have velocity x dot. So then the damping provides an opposing force to that motion, and the damping force is Ch dot. And now other external force is F of t. Now roller, you have a force N here, but that is in the vertical direction. So this is what is my free body diagram. Okay, and the effect of all this will be the mass getting an inertial force, which is mx double dot, mass into acceleration. So acceleration is represented by x double dot. So this thing is called as your inertial diagram, the right side inertial diagram. So the left side is basically all the forces represented on a free body diagram. The right side is basically all the inertial forces, because the mass can only move here in the x direction. So I have returned only the translational inertia, which is mx dot. Now what we need to do, use the Newton's second law, balance all the forces here to the right side. So let's take the x direction positive in this direction. So sigma fx is equal to the mx double dot on the right side. So for forces on the positive side of x is taken as positive. So f of t is positive, minus k1x is on the left side, so minus ch dot is on the left side, so minus k2x is on the left side, so minus, is equal to mx double dot, which is on the right side, so positive. So now let's take all this on the right hand side. So f of t is basically mx double dot plus k1x plus k2x plus ch dot. So let's put the acceleration term first, then the velocity terms, and then my normal x term. So that is k1 plus k2 into x and f of t. So just rearranging this, bringing an entire thing on the right hand side. So k1 plus k2 into x is equal to f of t. So let's look what are the options. So the answer is B. This is simple. You just need to draw the free body diagram equated to the inertial diagram. The answer is B. Thank you.